Good morning, grade fives. I hope I find you well. Welcome to our third term 2020. Today we're going to have our revision for the next test. So get your papers ready and your pen ready. We're going to revise together, okay? We're going to take a look at our maths test. We'll try to move fast and revise our paper. Okay. Number 1A says, write the following in ascending order. I have 4,000. I have 1,000. You can take the numbers down, Takuta. I don't know who this is. Unlock your video. Galaxy J7, unlock your video. 4,000.
It says that good or
Sorry?
it's good or Sean. It said that Jude or Sean Galaxy.
Yes, it should be Jude or Sean, between the two. Okay, ascending order. I said 4,000, 1,000, 6,200, and we have 7,300. Ascending order. What does ascending order mean, Takuta? When we are saying ascending order, what do we mean?
We mean we start with the smallest one going to the biggest.
Yes, ascending order, we are starting from the smallest one to the biggest. This is the normal way of numbers. When we are saying 1, 2, 3, 4, 5, 6, 7, 8, that's ascending order. The normal way arrangement of numbers. Okay, so can you ascend for us there, Takuta? Which is the first number that we're going to have if we're writing in ascending order?
The first is 1,000.
Yes.
Followed by 4,000.
Yes, the next one.
Then 6,200.
Yes, the last number.
And the last is 7,300.
Oh, 7,000 there. Good, Takuta. The next number, number 1B, write it in descending order. I have 1,000. These are my numbers, 1,000. The next number is 7,000. Then I have 2,000. And then I have 8,000. So I have 1,000. I have 7,000. I have 2,000. And I have 8,000. What does descending order mean? Descending order is the opposite now. The opposite. Yes, Takuta, I wanted to say something. Descending order
is starting with the biggest going to the smallest.
Yes, now is the opposite. You're starting from the biggest going to the smallest. Whenever a rocket is taking off to space, it uses the descending order. When a rocket is going to space, it uses the descending order. It goes 5, 4, 3, 2, 1. Then boom, it's going up to the moon. So the descending order, just remember the rocket, because I know at grade 5 we watch our cartoons, we know how the rocket takes off. It uses the descending order. So now, Takuta, can you descend these numbers for us?
We start with 8,000.
Yes.
Followed by 7,000.
Yes, 7,000. The next one.
Then we go to 2,000.
Yes, and the last number.
And the last is 1,000.
1,000. Good, thank you, Takuta. Takuta, what is the value of the underlying digit in 9,126 underline 6? What is the value of the underlying digit in 9,126? When you get a question like this, we use the abacus, okay? You must use the abacus. I have underlined 6 there on the value of the underlying digit. What is the value of that 6 there, Takuta? TC, can you hear me?
Of 6 is 6.
6, yes.
Because it's a unit.
Yes, 6 is a unit. So you can write 6 or you can write 6 units, okay? That is how we deal with
Yes, ma'am.
values of the underlined digits. Now we want to go to Roman numerals. Roman numerals. Roman numerals are numerals which were used by people called the Romans. Okay, they use symbols. Mostly these symbols, you can find them on the alphabet. They use alphabetic symbols which represent certain numbers. Okay, an example, we have 10. 10 is an X. That is the Roman numeral for 10. And then we have 100. The Roman numeral for 100 is a C. Okay, so these are different alphabetic symbols that are used to represent a certain number. Oh, it's Takunda there. Takunda, can you see me? Can you hear me, Takunda? Yes. Takunda,
Ma'am.
is it hospital? Are you still at Impilo, Takunda?
Yes, ma'am.
How are you feeling now, Takunda? Takunda is not feeling well. Thank you for joining us from Pilo there. I cannot see you proper. Do you think you can go somewhere where there is a little bit of light? It's a bit dark. Yeah, now it's better. Now it's much better. How are you, Takunda?
I'm fine.
You're fine. Okay, that's good. Okay, Takunda, we are here revising our maths end of term test, okay? So you can just participate with us, okay? Can you hear me properly?
Yes, ma'am.
That's good. Okay, we are doing Roman numerals. Uh, I was talking to TC here saying that Roman numerals are symbols, alphabetic symbols that we use by people called the Romans, and they represent certain numbers. Okay, I was saying an X is a 10, a C is a 100, we have a V, which is a 5. Those are mostly the basic Roman numerals, and we have an I, which stands for 1. Okay, so these are the different Roman numerals that were used, are used to represent certain numbers. So, who can give me the Roman numeral for 49? The Roman numeral for 49. A number like 49, you look at the closest, it's closer to, oh yes, Takunda is raising his hand. Yes, Takunda, the Roman numeral for 49.
LX. LX.
LX, if the X comes after, it's plus 10. So it's the X has to go away, Takunda.
Okay. XL.
XL, then XL, that's 40, correct? Then we need the 9 now.
XL.
XL,
XL.
yes,
I.
yes.
X.
Good, that is good. So remember that with the Roman numerals, we use the nearest. You remember rounding off. You must make sure that you look at the basic Roman numeral. 49 is closer, or we say to the nearest 50, right? If you're saying 49, if you're rounding off to the nearest 10, 49 is closer to 50. So you use the 50. And then from the 50, you create a 40. How do you create a 40?
Ma'am.
Affecting 10. Yes, Takunda?
Sorry, ma'am.
Yes, Takunda.
I'm not going to the doctor.
Oh, you're now going to doctor. It's okay, Takunda. Thank you for coming in and joining us, okay? Get well soon, Takunda. Okay.
Thank
I
you.
was saying that Takunda is coming to us live from Pilo. He's not feeling well. He's in the hospital, is now going to the doctor. Okay, I was saying that when we are dealing with Roman numerals, we use the rounding off method. So if you want to create a 49, you use the 50. So you must always know that the 40 is the X must jump before, like subtraction, okay? It has to be go before the L, and then 9 as well, rounding off to the nearest 10. If you're rounding off 9 to the nearest 10, it is 10. So you use the X to create a 9 by subtracting 1. So that 1 has to jump and go before. Okay, then the 11, you say 10 plus 1. So the 1 jumps after. Yes, okay. Takunda, Michaela is joining us. I'm sure she's going to find us. Let's create, sorry, Takuzo. Let's create I have 115. Can you give me the Roman numeral for 115? 115. 115. Yes, Takuza?
It is C
Yes, C?
L.
Yes.
L.
You said C? I said 150.
L.
C?
And then L. C L L
If
L for
I said 115, 115, not 150.
15.
Yes, I said 15, 115, 115.
It is C
Yes,
X
yes,
C X V.
yes, CXV, good, yes. Sorry about that. I think Takuta did not hear me properly and he has given us the correct answer. 115, 100C. And then you say, now you have 100. So you need a 15. We get the 15 from X, right? And then you add plus 5. That would be 100 plus 10 plus 5 plus 115. Okay, now we want to talk about Arabic numerals. Arabic numerals are the normal numbers that we use. The numerals that we use, the 1, the 2, the 115 that I was talking to you about, those are the Arabic. So now we want to change a Roman numeral into an Arabic. I have this one. It is LXV. 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 Can you try and change that to Arabic? Yes, Takuta?
It's 65.
65. Good, thank you. Good. Okay. Now we want to look at mixed numbers. We want to change improper fractions to mixed numbers. An improper fraction is a fraction that has a bigger number on top, a bigger numerator, and a smaller denominator. Okay. Usually I say an elephant balances on top of a goat. That's why it's improper, because we cannot find an elephant balancing on top of a goat. Takuza, you cannot balance on top of Carissa. Maybe you want to reach out to a ball on the roof,
Yes.
and say, Carissa, let me climb here on top of your shoulder so that I can get something on top there. That is an improper fraction. Okay, so you have 20/7. That is an improper fraction. You want to change it into a mixed number. Okay, so this over means 20 divided by 7. That's what it means. Okay, so when we are changing to a mixed number, we say 20 divided by 7, right? 20 divided by 7 is 2, remainder 6, right? Sorry, you say 2, remainder 6, right? And then now, we want to change this to a fraction. It to be equals to 2 is the whole number. Then the remainder 6 goes up, it becomes a numerator over. The denominator is 7, the one that we use to divide. This is how we change it into a mixed number. Let me give you one sum to do. Remember, I said we are revising. So if we get a concept, we look for another one. May you kindly change 8 divided by 3. Change it into a mixed number. Or we call it a mixed number or a mixed fraction. Remember terminology, so don't be confused if you hear them saying mixed number or mixed fraction. It's the same thing. I think Michaela is trying to join. I think there's a network problem. I hope she's going to join us before we end our lesson for today. Yes, Takuza, what did you get?
2 the whole number and 2/8.
Yes, that is correct. Yes, that's how you change from an improper fraction to a mixed number. Now we want to change from a mixed number to an improper fraction. Remember, we said we are revising. These are the concepts that we will have to know before we kickstart our third term. And remember, we are moving on to the next year, so we need to know all these things. So now we are changing a mixed number to an improper fraction. A mixed number is a number that has a whole number together with a fraction. Okay, if you say I have 2.5, we call this a mixed number or a mixed fraction. Okay, where you have a whole number together with a fraction. So we want to change this mixed number into an improper fraction. What we do is you have 2.5. So you put your arrow here, 2 and the 2, which is the whole number, and the denominator 2, they're going to multiply, right? And then the answer you get, you are going to add with this numerator. So what we do is we say 2 times 2, which is equal to 4. Then you say 4 plus 1, which is equal to 5. Your answer becomes 5 over the denominator 2. Did you see it there, Takuta? Yes. So if you are changing to a mixed number, you can use, when you put these arrows in a, let's say in your work, it shows that this is working. Okay. So you are saying 2 and 2, they are going to multiply here, right? And then your answer you're going to add with the numerator. That's what I've done here. I said 2 times 2, 4. Then I said 4 plus the numerator 1, 5. And my answer becomes 5 over 2. Okay, did you get that, Takuta? Good. Okay, let me give you a sum to do. Can you do
Yes, ma'am.
8 and 9/10? Change it into an improper fraction. 8 and 9/10. Change it to an improper fraction. Ma'am?
8 and 9, 10.
Folks, folks. 8 and 9/10. Change it to an improper fraction. Change it to an improper fraction. Thank you.
It's 8 and 9 tenths.
Tenths, yes. 8 and 9/10. 8 is the whole number. 8 is the whole number, then 9/10.
I am done.
Oh, you're done. What did you get, Takuta?
It's
Yes.
89 over 10.
89 over 10. Yes, that is correct. Thank you, Takuta. Now we want to find the highest common factor. Do you still remember the highest common factor? We want to look at the highest common factor. I noticed that in the test, there were some people who had challenges with that. That's why I decided to revise so that if they are going to be able to watch this and see the highest common factor. We want to look for the highest common factor.
Over 10.
Yes, the highest common factor for
18.
Yes, Takuto, can you hear me? Can you hear me, TC? We want to find the highest common factor. TC is unfortunately, I think his network is bad. We want to find the highest common factor of 4 and 6. The highest common factor, it is commonly known as the HCF. It is commonly known as the HCF. So the highest common factor for 4 and 6. When you are finding the highest common factor, you put your numbers like this. You have your 4 here and you have your 6 there. So you want to find the highest common factor. So what you do is you start with the 4 there. So you divide there. Oh, Takuta is back. Welcome, Takuta. Can you hear me now?
Yes, it's now okay.
Yes, we want to look at the highest common factor. It is abbreviated as the HCF. Okay, so when you find the highest common factor, they give you two numbers. They say find the highest common factor of 4 and 6. So what you do is you put the 4 here, you have your line, your 6 there, and you put your line there. So we look for the smallest factors that can divide, and we usually start with the 2. The 1, we know that if we divide 1 into any number, the number becomes the same. Like if you say 4 divided by 1 is still 4. So we start from the 2. So when you make sure that you always use the smallest factors like the 2, the 3, the 4s there, okay, before you go higher up. So we are going to start with the 2. So we are going to say 2 into 4 is a 2. 2 into 2, 1. Then we come to the 6. 2 into 6, 3. 3 into 3,
1.
right? So when you are done with
3.
this, yes. Did you manage to get this part tackled up?
I'm writing it down.
You're writing it down. Okay, I'll wait for you. We still have a few more minutes so that you can take it down. I noticed that people usually, they forget about the highest common factor. I'm hoping that we can do the lowest common factor before we end our lesson for today, so that my work that I'm going to send you to have this. Okay, so now that you are here, we do the ticking method, okay? So we tick now. So make sure that whatever number that you tick, it must be common. It must be there, both sides, okay? Both numbers. So we have the 2,
Yes. Yeah.
the 2 there. You tick it twice, but you write it once. Then you say 2 times, right? Yes. And then you are waiting. Is there any other number? Here there's a 2, there's a 3. There's nothing else. The only thing, there's a 1 there. There's nothing there. So which means it's 2 times 1. There's nothing there. The answer is 2. Okay. Or it's a 2 only, because you have the only thing that is common now there is the 1 and the 1 there. You have the 2 and the 1 there. So you just say 2 times 1. The answer is a 2. Did you manage to get that one there? Okay, all right. Let me give you, find the highest common factor of 4 and 2. Find the highest common factor of 4 and 2. It's also a simpler one.
2.
Start with the simpler ones. You are able to grasp the method, and then you can do even other questions as well. Find the highest common factor of 4 and 2. Use this method of ticking. What did you get?
I got 2.
Got 2. That is correct, TC. Correct. Now we want to look at the LCM. We still have 4 minutes before our lesson ends. I'm sure that's a lot of time. So the HCF and the LCM, they are almost the same, okay? But they differ. So we have the LCM. The LCM, the HCF, we're looking for the highest common factor. Remember, a factor is a small number that can divide into another number. That's a factor. So a factor must be a small number. The LCM now, we are looking for the lowest common multiple. A multiple is a bigger number now that is a factor can divide into. For example, 5 is a factor, right? And 10 is the multiple. So this is different from the LCM. Here you might find that you are getting bigger numbers than when you're finding the highest common factor. With the highest common factor, you're getting the 2s, the 3s, the smaller factors. But with the LCM, you are now getting the bigger numbers because you're looking for the multiples. But still, you're looking for the lowest multiples, the lowest common multiples. Okay, so the LCM, want to find the LCM of 6 and 9. So I have my 6 here and I have my 9. The difference with the LCM method is that you draw one line against both numbers. Okay, so make sure you don't get confused with the two methods. With this method, you put the numbers together, right? And then you draw the lines against both numbers. Michaela is joining us. I hope that she can join us so that she can hear this one before we end our lesson. So now, When we are dividing, we are going to use, Michaela, unlock your video and unmute yourself. So when we are dealing with this one, we look for the small factor as well. We are looking for a small factor that can divide into. Michaela, how are you? How are you? You're fine. Okay, welcome. Unfortunately, it's 2 minutes away, but we still have something that you can learn, okay? All right, thank you for joining us. All right, we are looking at the LCM. We are revising our test, okay? Our maths test. So we are looking for the LCM of 6 and 9. I said when you're looking at the LCM, you put both numbers inside and then you have one line there, okay? So you are having both of them together. So we look at the smallest factor that can divide into 6 and 9, and it doesn't give a remainder. Which one can we start with? We can start with a 2, right? Yes, we can start with a 2, right? So we say, if we say 2 into 6, that's a 3, right? And then we say 2 into 9, it can't, it leaves a remainder. If it leaves a remainder, you just bring that 9 down. Don't worry about it, just bring it down, okay? Yes. So if it leaves a remainder, just bring it down. Don't worry about it. You draw the line. Now we come here. We're looking for a factor that can divide into 3 and 9. It's a 3, right? So you put your 3 outside there. 3 into 3, 1. 3 into 9 is a 3, right? And whenever you are done, if you have a 1 there, you know that now you are done with that side, okay? Now we look at another factor that can divide there. It's 3. So you just bring down the 1 there. 3 into 3, 1. The moment you have a 1 and a 1, you are done with your working, okay? Your working is done. Now you need to look for your answer. When we are looking for the answer for the LCM, we multiply the factors that are this side, okay? This is where we get our answers. So which means our LCM is equal to 2 times 3 times 3, right? So are we together there, Takuta? Okay, Michaela, are we together? Okay, so we say 2 times 3, that's a 6. Remember, in the multiplication, you are carrying the multiplication. If you say 2 times 3, you get a 6. Then you say 6 times 3, right? So you say 2 times 3, 6. Then 6 times 3 is equal to 18. So the LCM, or the lowest common multiple for 6 and 9, is 18. I hope you managed to understand that part. Unfortunately, we have come to the end of our lesson, but at least, Michaela, you managed to get something. I am going to send work for you, okay, on maths and English. Okay, maths, I picked up a few sums that I noticed were a bit of a problem to people, and then I'm going to send you. Thank you so much and have a good day. Remember to write the work, okay? So, bye, guys. See you again tomorrow. Bye, Michaela. Bye. Bye, TC. Bye. See you again tomorrow, okay?
Bye.
Bye.
See you again.
See you tomorrow. Bye.